Hey guys, welcome to our talk. We're about to get going here. Thank you for showing up. We probably won't have time for too many questions, but we'll be around all lunch and hanging out. So definitely come up to us, ask questions after this. So I'm Daniel Nahara. This is Lyndon Sirk, and we're with HNTB, a civil engineering firm. And this is our talk on transforming infrastructure design with Unreal Engine tools. A little bit of the agenda we're going to go over. We're going to kind of give you a framework of where we come from in the industry, some of the projects that we deliver on, and then go into all the tools and ways we make this workflow efficient with Unreal Engine. So who is HNTB? If you've never heard of them, we're basically a civil engineering firm that specializes in doing all the engineering for aviation, tunnels, subways, lots of trains lately. I started my career just building miles and miles of highways and roads and city buildings. So it's been a fun journey, and I'm really glad to be here. I also want to say thank you to the Epic team for having us here and guiding us on this mission that we've had for the last 7 years. And I see a lot of familiar faces like Rob, Christina, Steven. You guys have been really helpful in getting us here. So thank you guys. Talk to them, engage with them. They're just ready to feed you their knowledge. So we come from the creative media studio inside of HNTB. We're basically storytellers at the end of the day, and we're listening to our marketing teams. We're listening to the engineers on what's important to them and what's valuable message they want to tell at the time, and we guide them through the storytelling process. Our team has 4 different disciplines: graphic design, motion design, cinematics 3D team that's primarily in 3D Max and V-Ray, and then our immersive Unreal Engine team that is exactly why we're here. And then our tech team that is the foundation of everything we do. They back us up in all the weird asks. As an artist, I don't know how to script. I don't know how to do a lot of the cool plugin tools that they create for us, but they make my life so easy, and they support the entire department, which is really a godsend for us. This is a look at our team. Most of our people are from VFX, games. We have a couple architects, engineers. We are basically just a diverse group. We're looking for fine artists as well. So I love working with these guys because they have to specialize in one thing and then generalize in a couple, 2 or 3 other things. So we really do a lot of things, and I really want to show some of the different type of work that we do real fast. This is all some of the Unreal projects that we did last year. So you're going to see a lot of train work that we do. And one thing I want you to take away from this is that we're not just going for a pretty image. We're trying to find value in the storytelling. We're doing this with construction phasing. Sometimes we're doing these with layouts and just getting the oversense of the plan, of the idea of how we're going to change these cities. It's really important that they walk away with a guided message, not just like, oh, it's going to look beautiful, but how's it really going to impact the city? How are people going to flow to these new environments, and how are we going to integrate what's already there? What I love about this one, we got to work with local artists on the graffiti design that will be on these walls in the future. And we hope to have some type of immersive display there one day. And then we get to do projects that go over 50 miles, 100 miles. And we have to do different stations along these ways. And each of the stations can be described in different ways. And this is the flexibility that Unreal Engine really gave us. And instead of being locked down into just one path that we had to say, hey, we started this as this type of project in the beginning, we can't change it. Sorry, guys. Unreal gave us the flexibility to change things. And one of the first things people were asking us is, how long does this take? And I would tell them, well, which part? The reason I say which part is because they may have a meeting in a month that they need to talk to people about the mayor's office of the pedestrian flow. Next month, they may need guidance on how the electricity is being flown to these subways. But they need to have engaging visuals to tell this story. So every step of this way to the interview, we might have to change the visuals from an aerial walkthrough to VR to something on pixel streaming. Maybe they are going overseas and they don't have internet and we have to create a different solution. So Unreal Engine really gives us the flexibility to open it up and really dive in and change the story. And then you can see from this graph, it just becomes a spaghetti mess of different types of deliveries with new sites being added all the time, updated designs. This is a hypothetical, but not too far from reality type of diagram. And what's great about all this, we could export to a digital twin pretty much anytime we wanted to. And they find a lot of value because we're filling in the gaps. We're usually working on these projects well before the engineering is being done, so they have an idea of what's happening, but we're asking the questions all through these steps. This is just another little, like, how these deliveries can just expand over these months of deliveries. So how do we get these projects started is usually the first question people ask us. The team has created an incredible amount of tools to basically ingest all these different data sets. These are just the most common that we get associated with, but I probably have like 30 different programs that I only open once a month, and I don't know how to do anything except for the export. But the team has a really great script for us that takes it all the way through our repositioning for our 3D Max DCCs that they've created, and they write little JSON files that keeps basically the data for this that we can look up what the new project coordinates. So if we ever have to go backwards, it's a simple process. And then our terrain import, I'm going kind of faster because again, I just wanted to give you all a framework of where we're coming from. We'll get into more of the Unreal stuff, but these are some of the ingestions. And this is time by our import process from Nearmap, USGS. USGS is GIS service that has tons of information. The link on there is a great place if you wanted to get the OpenStreetMap roads, footprints, and get something kind of started pretty early on your phase. We take this into Global Mapper. We dissect it in Global Mapper. We do this all in Python, so it's optimized. We send this to 3D Max, and 3D Max talks to the Houdini engine that can basically, we have parameters of how dense do we want our meshes to be, increase the curvatures of GIS vector data, and you come out with something that kind of looks like this at the end of the day, where it's kind of guided, it's optimized in powers of 2s, and this process basically used to take us 2 weeks. We got this down in a couple hours. And on top of all this, once we build our detailed area, we have cesium nowadays that can just fill in the background data. So that mountaintop in the background, this shot was done last minute. We didn't know we were have to shoot this angle. And luckily cesium was there to help us fill in that background area. And then another tool that we have is creating the template or the Unreal file. For an artist like me, I just enter in these 2 parameters, a project name and the create Unreal project and the locations. And then it plugs in all this, our connector plugin, which connector, if y'all are aware, it's basically our repository for all our assets and materials, our Houdini plugin, then our master blueprints, and all our little scripts that we're going to need along the way that Lyndon's going to go into detail here in just a moment. And then the first thing that every project manager wants to know is how can we show phasing? That's usually the most common request that we were always getting, and we said no for the longest time. Or how long can we have 6 months to phase every little PDF item, every little beam, and then, oh, you want to change it? Oh, it's a drag. Like, nobody wants to do that. Nobody wants to change it, too. So these guys, we're going to let Lyndon kind of explain all the hardship that he went through, him and the team has gone through to make this process a really fluid way of going.
All right, so what we're looking at here is a construction phasing schedule. This represents 1 page of maybe like a dozen pages of very specific phases of a project that the client might want to see being built in our animation. So each row represents a specific phase with specific dates for what components need to be shown or removed, or like added to the project or removed. This traditionally has been very, very difficult for us because these schedules change all the time. So once we build out an animation in 3ds Max, changing even just one component of that can cause like a cascading effect where every other piece of our animation also has to be either removed or offset. And sometimes it was easier just to completely start over. So we knew that we had to have some way of automating this in Unreal. So this is our construction phasing tool. So we have to start by ingesting this data from this PDF into some type of like Excel sheet or a CSV file that uses the activity or phase IDs, along with all the mesh IDs from 3ds Max. And of course, with the start and end dates for the actual project and how many frames we want that to show in the animation. So this is a manual process, unfortunately, but we can do this completely in Unreal without this step if needed. But here we have a typical CSV file that has the activity or phase IDs, start end dates of the actual construction project, or that phase of the construction project, and how many frames we want that to start and end, along with the 3ds Max ID names. And for IDs, we just use a basic prefix. So on the first one there, we have sheet piles 1 through 17. If all of the sheet piles have the sheet pile prefix, it's going to grab all of them and assign them to that phase. We also have animation types and whether we're adding or removing objects in that animation. So for this, we use scriptable tools inside of Unreal, and we have preset animation types. And we use a Python script to normalize the times to the overall length. So the date and times that we are given, those are locked in, but it's kind of arbitrary of how many frames we might want to use for the animation. Once all of this is locked in, we can then decide to edit it later if the schedule changes. So we can apply all of these to Sequencer, and then all we have to do is open this back up, change the values, and then reapply it to Sequencer, and everything will just fit into place. So here's an example of this bypassing the manual CSV. So if you were just wanting to create one simple section of a phase, you can select all your objects, grab them from the outliner. You can change animation presets if you want. And then we just head over to our PDF where we grab the phase ID just to keep everything organized. We can paste that in. Now this can also be automated as well, but this is just showing the tool if it wasn't pulling it automatically. We grab the end dates, and then for here, we can just leave the frames on default just to show how this works. And then we simply create the animation. And then all those pieces will just fall into place. So then we can clear the scriptable tools section. We can go on to the next phase, grab other elements, and do the same thing. Here we can change the animation preset if we want to. And after all of this data is applied, we can then go back and then edit each one of those groups. And it's much more easy to do this than having to go back to 3ds Max and then re-export out a Datasmith file. The last part about this is that we have this all interactive via a timeline slider, so the client can move around in real time if we're pixel streaming this. And here's an example of this. All our UI elements with a blueprint are just easily adaptable, just based on the start and end dates or how many days the project is going on for. We don't have to recreate a new UI for each one. It's very quick to do. Here's an example of the entire thing working, where we have an example of a highway. You can open up each specific phases, and you can grab like the notes for that section and see in real time which part of that project would be constructed at the certain dates. And if we need to make a change, all we have to do is go and edit the dates in Sequencer and reapply the update, and it will just fall into place. We also have an interactive callout system. So this is a system if we want to be able to specify a specific location or like a hotspot of an area. This is rendered either in world space or screen space, depending on what we need for the project. And we have a DCC export script. So in 3ds Max or Cinema 4D, the artist can create dummy objects for where these callouts have to be. And then we export that to a JSON file. And then we import that via a UData asset. So we import that into a data table. And then for each row of the data table, we assign a blueprint actor per callout. We also can draw stem lines really easily via a widget blueprint. And that's how you do that. It's very simple to do. And here's an example of a construction sequence with callouts as well, where the client can, or the user can specify what they want to see on screen at any one time. We have multiple different camera views, and we can see the construction working over the course of many years. So you can scrub the timeline, you don't have to let it play, and you can also change what elements are showing on screen. And we found this really useful when pixel streaming. So I'll just let that play. So similar to our callout system, we use interactive charts as well. So if the client wants to display some other type of data, so if, for instance, the associated cost per phase of the project, we can ingest that data and display it as well. So this is very similar to our callout system, except this is purely a screen space render. We still import the data into a data table asset via like a CSV file, or we can just manually input it directly in Unreal if we want to. And then we simply the height of the bars is normalized based on whatever the input is. And that's how you normalize bars. We use 1 bar per blueprint actor, which is not the most efficient way of doing this, but it was the easiest for us to set up when we were developing this. So this works fine if you have like a limited number of widgets, but we are aware that if we created a UI material, this would be a lot more optimized. So something we will work on in the future, but we can just do it with 1 blueprint actor. And here's an example of the chart system. If we have data that the client wants to show and they provide us that data per phase, it's very easy to ingest that data and then just click a button to toggle it on. And that just renders in screen space on top of whatever camera is being shown. OK, so Daniel already kind of touched on our aerial data and how we import it. So this is the process. We get everything from near maps. So this is all of our terrain data. We have the color maps and also data maps. Everything is projected in Global Mapper, and then that goes to the DCC, and then from Datasmith to Unreal. So we use AI data layers from Nearmap to capture other components of the scene. For example, we have, on the right image here, we have trees, grass, asphalt, and concrete, and those are packed into an RGBA image. We found these to be the most useful ways of being able to utilize data inside a blend material, and I'll show you this process here. Very simple to do. Once we have exported the Datasmith file from 3ds Max, we simply load that in. We select where those terrain file or the terrain images are, and then the terrain masks too, or the aerial masks. And once all 3 of those components are added, it combines them all in 1 level here. So this is a real-time look at that. And the next part about this is when you zoom in, it lerps between, or it's not a simple lerp, but we're basically blending between that aerial image and also tileable, higher resolution elements for grass or concrete, asphalt, dirt, whatever we want to add. This allows us to place the camera wherever we want, and it's because quite often we don't know where the camera is going to be. And we can move around. And of course, if it's a road, we will model the road, but sometimes there might be like a non-hero section that's still pretty close to the camera. And if we didn't have some kind of way of blending them, we would get a very low resolution image like this. So this with the blend off, and with the blend on, we can still maintain some of the macro detail from the terrain, the aerial map, but we can also get some higher fidelity as well. So if you look at the striations in the grass in that field there, that kind of detail we still wanted to preserve. And we used some lerping with some other little techniques just to blend some of the terrain back in. So once you blend it, it is going to change the color, but you can color correct every element of it. All the channels can be color corrected, but it still maintains some of that macro detail while giving you a higher fidelity image. The packed data layers look something like this. So sometimes this is useful for either debugging purposes or simply seeing where things are. So on our material instance, you can simply turn this on. And this is a look at just the tree map, which leads us into the next section, which is about PCG trees. So we used to do this with a HDA, so talking to Houdini to determine the tree placement. But when PCG came out with more tools, we thought we would do this all in PCG. So we wanted to automate the placement of trees just based on that aerial map that we got from Nearmap. However, there's a slight problem when you're trying to sample a texture using PCG. So if you look at the lower image, the white section is the actual tree map data where all the pixels are mapping to where trees are on that map. And the upper image is where PCG decides that, oh yeah, you can have trees here. So instead of using like the individual pixels, it kind of just divides up your texture into grids. And based on the number of white pixels from the tree map in that specific grid, it gives you a weight of how likely there is to be a tree there. Well, this is very problematic for us because we need to be able to specify on very large maps where trees can go down to like the foot, because we don't want a tree to spawn in the middle of a road, for instance. So instead of trying to mess around with PCG, which we probably could have done, but we decided it was a bit more efficient and allowed us a lot more control to spawn a separate Python process using OpenCV. So this is something that we spawn in from Unreal, which I'll show in a moment, but it launches a separate Python multi-threaded process that looks at the tree map data and then decides based on some custom parameters where trees are likely to be put and how close enough together they are, and it then will give us back data that we can import into PCG again. Here's an example of this working. We simply select the terrain tiles that we want to use. and then we select the aerial masks that were provided that we grabbed from Nearmap and then packed. We also specify the maximum number of trees that we want for that entire region. And this, again, is real time. You can see how long or how slow it takes, depending on how you look at it. But this is spawning a separate task and determining all the tree placement. Now this is going to create like a one giant PCG instance for the entire terrain. Here we can add other trees, and there's a whole bunch of other parameters that we can add in the future once we determine what we want to do with this data. But here is all the points that OpenCV created. So instead of using this in PCG, we're just giving the points to PCG and letting it decide where the trees go from there. So if we zoom in, all the trees are already done. And if we wanted to tweak the values, we can do basic things like self-pruning. It's very simple to do inside PCG. But if we want to completely change like the direction of where trees are placed, we can just nuke it and then just redo it from the script. The other really useful way of, why we use OpenCV is that we can then take the road masks or any other type of masks and subtract them from the tree mask. So quite often, Nearmap would provide an image that has a tree that's overhanging a road, and it doesn't know that there's supposed to be a road there. So you can simply subtract specific maps, and then it's never going to have a tree going in the middle of a road. The other thing that we can do with this, which is not shown here, if we realize we still want trees to be in a specific area, we have a tool that allows you to just draw a basic spline, and it's like an include mask. We also do the same thing for exclude masks if we want a specific region to not have trees. We use PCG for other things too, like grass and rocks. And here we have a tool that allows us to grab the outlines, basically, of all of the paths. And then we can pull that back into PCG, and it's only going to do grass around those sections. So we don't have to manually draw out splines. Very last part about aerials is if we're color correcting aerials or we're doing any type of color correction or any type of instance transfer, it's not a really good way to do that inside Unreal by default. And if you're color correcting terrain, you're going to want it to apply to all the other tiles. So instead of using a material parameter collection, which are a little bit more cumbersome to use and don't allow you the full data set, we decided to just make a really quick Python utility to select an instance, then select all the other instances that you want to transfer your parameters to, and it will do that very quickly. So you can see all of the terrain is now color corrected based on that one tile that we had selected. OK, so this leads us into materials and post processes. We have, this is going to be probably the largest section of this talk, and there's kind of a lot to cover, so I'll try to do my best to get through it all. We wanted to, or our mindset going into this was we wanted something that's very fast and artist-friendly, but we also wanted to encourage quality and performance. So for us, robustness wins over performance most of the time because most of the things that we're doing are just rendering frames, or we're pixel streaming, and we can handle more complex materials. We also wanted to have a flexible workflow. A lot of the artists that are working in our team don't ever need to use Unreal. We just need assets that they give us. Those artists want to work completely in 3ds Max and do all their material assignments in Max. And then someone like myself would prefer to do everything in Unreal. So we wanted to have two different types of workflows and support both. So for this, we use the connector library. Connector is just an asset manager that allows us to sync our materials between Max and Unreal. So we have the same materials on both Max and for Unreal. This is a unified location on Perforce as well. This keeps things really convenient. Also allows us to curate all of our materials and other assets. And like I said, it syncs between Max and Unreal. This also improves our custom Datasmith import process, which is the next section. If you're not aware, Datasmith is a plugin for transferring data from 3ds Max and Cinema 4D and other CAD tools to Unreal Engine. However, there's some problems with the default version that we needed to extend. So we have extended functionality in the form of some export scripts from the DCC and a custom import script when re-importing a Datasmith file in Unreal Engine. This allows the artist to choose their workflow preferences. And how our custom Datasmith works, basically, instead of allowing Datasmith to handle all of the material creation, if a material is found with the same name that exists on the Unreal side of the connector library, instead of having to remake the material, it simply grabs the already made Unreal asset and just swaps it out. So we don't have to waste time waiting for it to build materials. But if that material does not exist, we have a separate export script from the DCC that allows or it writes a JSON file. And if it's in the same folder as the uDatasmith file, it will read that first. It will create those materials that don't exist in connector, and then it still allows the artist to make a custom change. The other thing that our extension allows us to do is keep track of assignments in a better way. So instead of having random IDs for the mesh and material connections, we actually use the material slot names from we use the material slot names from the multi-sub object IDs in 3ds Max. This is a better way of keeping track of assignments. So when we re-import the Datasmith file, it quickly does a query to make sure that the incoming change will work with the meshes that we have already. So for instance, you could have 2 different buildings, but then you decide in Max you want to connect them so that it's just one mesh now. That would break Datasmith and you'd have to reapply all your materials again. But our method allows you to keep track of both and it will just merge them together and maintain those material connections. The last thing that our custom Datasmith allows us to do is assign an object ID on each static mesh coming in. And this is really useful for later on when I show some of the randomization. So for example, this is a project in 3ds Max. I wanted to grab a rust material for the top section of the bridge. So I go to connector, I just search for a rust material, drag that into 3ds Max, and here you can see the multi-sub IDs for the materials here. And then when we import that into Unreal Engine, it simply finds the Unreal version of that Rust asset. Okay, so we want everything to be robust and performant if possible. We do have the preference that the material is going to be as robust as possible, so you don't have to go back to the DCC, but we also want to try to limit our instructions because that can be kind of a problem if you just go crazy with it. So for speed, we want to reduce the back and forth between the DCC and Unreal. We don't really have any time for handcrafted textures, and we want, wherever possible, to match the functionality of the DCC. So for instance, the image on the right, the top image, this is an aerial map. In 3ds Max, it's very easy just to simply grab the channel of the color and just plug it into roughness. And we didn't have that ability to do that in Unreal by default, and we never want the artist to ever have to go into the material graph, and in fact, we don't want them to ever touch it, right? So some useful features that our material has is that base color can drive emissive, roughness, and normal channels. And this also includes options for downstream color correction too. So for instance, if you needed to change the contrast of your aerial, it's going to allow you, if you want to use that same version to plug into roughness. So this is part of our flexible options. Everything going into Unreal from our connector library is packed. So we use AO, we use roughness, height, and metallic. And we want to make sure that if you don't need or you don't have an AO or you don't have a height or metal map, that you can simply just ignore it and just say, no, let's just turn on use roughness only and just use my roughness map. I don't want to have to waste time packing something where all the other channels are just blank. We also do allow full non-packed options as well. So if you are trying to figure out if one specific channel is working, instead of having to repack it every single time just to test it, you can open it up and then you can just put in the individual maps. Now this is obviously not performant and we discourage it, but if this is found to be a problem, we can just disable the entire thing on our master material and we can just disable the functionality completely. But it's very useful for dev purposes. So we do have the mindset that if we can fix it in UE, do that. So we do still have problems with Datasmith and especially Cineware, which if you have never used Cinema 4D, we recommend that you don't use Cineware. You just go through the Datasmith approach, which we'll explain in a second. Some edits are just erased by re-importing, especially when you're working with PCG. Sometimes re-importing a Datasmith asset can cause PCG, if you don't pause it or you forget to pause it, just to spend forever recalculating. And it can sometimes just mess stuff up. And if you're needing to render quickly, just do it in Unreal. So one of the things that's very easy to do is fixing UVs. So for UV mapping, our material has, of course, basic transforms, but also everything has a single sample triplanar option as well. So if we realize an object is too difficult to unwrap, because we do not unwrap most of our objects in 3ds Max, we just box map everything. So if something has an incorrect UV, we can simply turn on triplanar mode and it will just map it fine. Of course, less performant, but it's only using a single texture sample, not a world-aligned texture using 3 samples. So this also supports normal corrections, of course. And we also have an automatic slope alignment tool. So for instance, you've brought in your building and one of the roof tiles has the wrong UVs, they're flipped. Well, you'd have to go back to Max, fix that one face, re-export the Datasmith file, and then you risk breaking other things. We do have a tool inside of an HDA that will automatically make a roof for you, but from time to time, we still get these issues where all the roofs are the wrong way around. So now you can just click one button, and it automatically will correct your roof tiles so they're all aligned properly. And we have different parameters to control how flat it is, because that's sometimes an issue. And you can also change the vector direction as well if you need to. Okay, randomization. So we do a lot of UV randomization. Everything has to be single sample, so we don't do any type of texture bombing at all. And we have various ways of doing color switching and HSV variation. Everything is also per object, so either based on that custom mesh ID from the Datasmith file, but if we don't have something from Datasmith, or for whatever reason it does not have its own unique ID, we can also do it by world position as long as the object does not move, or we can bake in multiple objects in one mesh by using vertex color to drive the randomization. So here on the left-hand side, we can see some grass that's tiled and looks really ugly. And we can simply just turn on a UV randomization, and it just fixes the problem instantly. If we want more control, we can add more instruction sets to be able to control the min and max for scale, offsets, and rotations. And we have various ways of controlling the cell scale. This uses a hexagonal grid. We can also change the blending between each cell as well, which you'll see momentarily right there. We can then just spread out the noise. So instead of using a texture sample to drive this, we just do it all procedurally. Sometimes that could be an issue, but we also like to be able to change the seed. Everything is using one seed for all randomization, but if we need a specific seed per subsection for like controlling specifically the randomization here of the UVs, we can enable like a custom seed for that section of the material graph. Here's an example of our color switching. So sometimes we just want to color code things. So this just replaces the base color with a set of colors, and these are weighted. So we could say something like 50% of all these houses that are instance are going to be red, 25% green, or whatever. So it's just a really quick way of being able to do that if we need to color correct something, or we just need to highlight something, but we don't really worry about the texture too much. Probably a more practical example, though, if we have the same instance, is simply altering the hue, saturation, and value. So we can do that very simply as well. So all of these houses have the same material, it's the same material instance, but based on the mesh ID, you're just tweaking the results. So you could increase the saturation, decrease the saturation, and there's a few controls for that as well. Okay, grunge is another thing that we like to add. So grunge is basically just any additional type of color or roughness map that we apply to it, but most likely it's going to be used for grunge. So this includes separate UVs, a separate randomizer, and blending modes as well. So for instance, we have a very boring looking wall, and if we want to break up the repetitive of it or the homogeny of it, we can simply just enable grunge. And that just makes it look a little bit more interesting, more real. But if you look, you can see that it is tiling and the randomizer is off, but we have a separate one, randomizer for grunge, that we can simply enable, and then you'll get rid of all of the tiling. So we have various parameters to control this, and we also have a leaks mode. So this, instead of using a standard type of grunge, we have leak masks. So we have a collection of textures with RGBA, all with different leaks. So something like these oil tanks here, based on the height of the mesh, we can have the texture aligned with that and use dripping leaks instead. The second part of this is for roads. So this is basically a grunge system, but specific to how we UV our roads. So if we apply the road section of this material, we have multiple different types of maps based on how we've UV'd the roads. We have to specify that in the material here. And we can basically take a very plain road and then enable a road grunge and then have tire treads. And we have multiple different ways that we can just flick through these images and find the right grunge that you want. So it's all just procedural, and it's just flicking which lanes have which textures. Our texture also supports texture arrays and atlases with one click. So nearly everything in this material is just a one-click toggle. If you want it, you turn it on, and everything, all the connections automatically will work. You don't have to go and replace everything. This also has a base color only mode, because quite often for a texture array, you want to just change some color. You don't want to change the normals or the roughness. And this is, again, very useful if you have one material instance. You only want to manage one material instance, and you want to throw it to many, many meshes. So this uses a texture array as an atlas as well, if you want to, because they're not mutually exclusive. So if a texture array, in case you don't know, is basically a U asset file that contains many, many textures. So here we have 16 different bricks, but it's all in just one massive array. So it's basically a collection of textures. So this reduces the number of instances that are required, so we don't need 16 separate brick materials, we just need one. This is also expensive, so don't do this for everything. You also have to use non-virtual textures, which can also be a problem depending on what you want to do. However, this does allow you to tile the UVs like we do as usual, because if you use a texture atlas, which is a very similar concept, so in this case, instead of having 16 separate textures all packed together, we're basically just using one single image, and then within that image, we divide it into a grid, and we place bricks on all of those images. This is great because it reduces the number of material instances and textures, because now you only need one. But the huge drawback here is that you have to have unwrapped UVs, which we don't really do most of the time. So we find this useful for things like billboards, windows, decals. So something more like this, where you're just having one little section like graffiti or something. You slap it on a decal. If you don't really care which decal has what image, you can simply throw this to thousands of decals if you want to, but it's one material instance controlling all of them. So here's another example of this. On the left-hand side, we just have a grid with numbers on it, so each number would represent a different texture. And with a seed, I can just move around the random assignment based on the mesh ID. And the same thing is true for texture arrays, too. You can simply say the texture array is also a texture atlas, and please just throw as many different variations of whatever we're trying to do, but just with one material instance. Here's a practical example of this. This is a stylization that we did for a project where we have each building is actually part of an entire block. So the entire static mesh represents maybe like 50 different buildings, but it's all one static mesh. And the vertex color is baked. So each one gets a different vertex color. Based on the vertex color, we're able to do the randomization. So the randomization allows us to apply a different brush stroke texture and a different like papery texture to each one. Here's a different view. You can see the road has a slightly different texture to the buildings, for instance. All right, so material layers. We find them to be quite cumbersome, actually, to set up. So we decided not to do that for a few reasons. And the second reason is it can be less performant, because there's no good way to limit the artist from just adding more and more and more layers. So instead, we decided we're just going to have a two texture set blend solution. So if the artist wants a little bit more control, you can simply turn on a second material set. This is again, a one-click toggle. We find this to be easier for artists to use. It limits instructions because it's easier for us to pipe in information upstream. And we can reuse parameters as well. So in this example, I have grass on this field, but I want to add dirt to it as well. So I can simply go up to the material and say I want to add a two-texture blend. And this gives us a second copy of all of our channels. So we now have base color 1, base color 2. And if I wanted to replace it with an existing instance, for instance, we can, instead of having to manually assign all of these dirt textures to that first instance, instead if I go back and I turn off the two texture blend and I grab both of them, right click, and just say, hey, make me a two texture blend of this, it's going to create a new instance and just automatically assign both of those textures. And right away, we've got both of them very, very quickly. Here we can change the blend masks, the contrasts, we can change the color corrections. We can also change randomizations for each one. So obviously, as every single texture had this enabled, this could be quite expensive, but most of the time, we only need this for a few different materials. We had a request come in a while ago for making a scene that was traditionally summer, if we could make it snowy. So this was a solution that, without much work at all, we could just override that two texture blend to be on for everything and replace this second set with a snowy texture. And then the only thing that we had to do there is specify that that second set could only apply to flat or flat-ish surfaces. And here we could convert the scene in just a matter of hours to having a snowy look to it. So as long as we didn't need a lot of 3D thick snow, this was like a frosting, this was a really, really great solution that was very simple to do. Okay, HLSL. We use HLSL quite a lot. The reason being that we try to aim for the same feature set across 3ds Max, Cinema 4D, and Unreal. So doing that allows us to use OSL on Cinema 4D and 3ds Max. And OSL translates mostly pretty easily to HLSL. There are some weird things. This also allows us to do things that we can't do any other way. For example, for loops. We can also use switch statements. And it also makes our graphs nice and small. So we have something like this as a hatch line generator. Very, very simple to, at least for a programmer like myself, to deal with. So a switch statement, these are really useful. So if you are going to use a lot of if-else statements, just use a switch statement instead. So on the right, this is like some basic code for doing a blending mode selector. So the full thing would look something like this, where you have 17 different modes that can be selected just with a scalar value selector. And based on the number that you input, it's going to choose one of the blending modes. And the blending modes are just directly from the Unreal graph. And based on the input that we're using, it just selects one and then inputs the base material or base texture or base color with the blend, and we get another output. If you're taking a picture of this and you try to implement this yourself, I have a slight optimization. Instead of flooring the selection node there at the bottom, you could simply just use, once it's ingested into HLSL, just use like a uint. It's probably more efficient to do that. I don't know why I didn't do that for this example. All right, so for loops, sometimes necessary. Not really too much to go on there. Fancy logic, so add all your stuff there based on, for some of the screen space things that we do, this is very useful. And here's a really quick pro tip. Most of the examples that you'll see online, if you're trying to do HLSL, they're very simple, and there's only one function. But if you wanted to have multiple functions inside your HLSL, your custom node, just wrap everything in a struct. Then you have access to all the different functions that you want. So here is like a very, very quick, simple example. You have some input, like a 3D UV set, for instance, and you want to add noise to it. Well, now you can throw in a noise type selector, and if that selection is 0 or not 0, you get 2 different types of noises. Again, here, you should probably not pass in a float through all of these. You pass in like a uint or something, but the functions is the takeaway from this. Downsides of HLSL, not artist friendly. That's a good thing sometimes. No virtual texture support though, so that's probably the bigger problem. So that's sad. So Epic, please give us support for that. Okay, so lastly, our materials are quite complex. So how do we manage all these problems? Each new feature set adds liability. So we have many material types that are very cumbersome to maintain. And we also have this 2-texture set blend that requires a whole bunch of parameters. So the solutions are, we like to use monolithic materials with a bunch of switches. Everything has to be self-contained within the material functions. This means that we have internal parameters for almost all of our functions, but we have external parameter overrides that we can use to just do something else from an upstream node. This improves modularity, and it also improves optimizations. So this is a look at our master material. It's very modular in nature. If you don't need certain things, you're not running those instructions. We just simply use a switch. The very first step, though, is something that I haven't really seen before, but maybe this is common, I don't know, but just to have like a parameter staging function. And here we have every single node or every single parameter that is unique for texture set A and B. So there's no logic whatsoever here. It's just all the parameters that we need, and we pipe that through another function. So this function is this is like a quick snapshot of like some of the parameter names that we might need. And these all get piped into another function that determines what to do with all of these parameters. So here goes our UV and channel functions. And each one of these has a subsection. We could wrap this into smaller and smaller functions, but at some point you just need to stop and just be like, okay, all of our channels are in one function. This is our base color, for instance. All those red nodes are the inputs to those functions. The outputs just get hooked up to a basic make materials attribute node. That's very simple. And if we are deciding to use that 2-texture blend, we simply use a blend mask to blend between material A and B. Now, I mentioned Cineware before. So when we were trying to use Cineware, we had a problem where Cineware used different parameter names for all the Redshift materials. So a very quick solution was just let's override our staging function that just has all the parameter names that Cineware is expecting. Then we can plug in our material, and we still get all the benefits of our own material instead of having to use their baked or their specific Cineware material. Problem with this is, though, that every time there was even like a hotfix, they seemed to break something, or they changed the parameter name. So eventually we decided to do this all through a custom Datasmith file for Cinema 4D specifically. It's much easier to change the logic of how it connects to our material that way. But this was a very simple solution that we could simply make sure all the parameter names changed. So this is probably the most important slide. If you are wanting to use internal parameters and also override them, there's a very simple interface for doing that. So we would have like a named reroute node that says, hey, are we actually going to override that? And if we are, please just use the function or the parameter input that we're, so the lower part of there is the input parameter. So just use that instead of the built-in one. So this is an example of our color correction node. all of these inputs here are not actually required for it to be working. So we could decide that let's just delete all of them and we still get the same functionality. So the only reason we're passing in parameters here is if we are wanting to use that 2-texture blend and we need unique parameter names for each. So the parts of that function that are having input, the input parameter interface are these parts here. And again, it's very simple to do, but it allows your functions to be a lot more modular. Okay, this for optimizations. Of course, we do favor robustness and workflow speed over the instructions. However, we do have a lot of different switches. If you're not going to use a specific feature, that feature is going to be off by default. And if you want to enable it, you can enable it. And if you realize, hey, I'm not actually using AO, I'm not using metallic, for instance, you can simply disable that entire channel and there will be no instructions added to it. And also use constants instead of texture samples, because quite often you do not need to load in a roughness map that is like a 50% gray. Just use a constant instead. All right, some quick tips. If you are trying to use embedded parameters, don't try to apply the parameter to the material preview default like this. This does not work. The reason is that only the external parameter piped in outside of this function works, but both display in the material instance interface. So you'll see them both when you're trying to edit the material, but only one of them does anything. You also should use unique internal and external parameter names. This is going to save a lot of confusion. You should also do some kind of like postfix or some kind of prefix on those internal parameter names so you know just by looking at it on the interface that this is an internal parameter. And this also indicates shared parameter too, because if you do see that little postfix, you know that it's shared between both sets or something is wrong. And you should also, another quick tip is that you should always prefix your named reroute nodes. So if someone's looking at this and has never seen that node before, it's sometimes a little bit confusing to know that it's actually just a reroute node. Last thing, you select all of these, click Q, makes it all straight. So if you have OCD, it fixes it. All right, really quickly, post-processes. I think we're going to run out of time here. For our stylization, we also do like a monolithic post-process material. It's monolithic in nature, so we can simply add on other functions. So if an artist says, hey, I'd really like to do this, all the logic for this material is stored inside each one of these nodes because nothing is mutually exclusive. We can simply add on another section. So we also wanted to avoid a separate material type for our meshes. So the post-process material would just be on top of it, but we don't want to have another one just for all the meshes. So we just use our master material for that. We want to offer as many robust styling options as possible. And we want to be able to have texture sample options and procedural options for nearly everything as well. So really quick rundown of this. We do cell shading, which is a very subtle effect here. We can quantize the number of steps between exposure levels, and we can also blend them, which is very useful. We have multiple different types of outlining and hatching. And we have Kuwahara effects that we can add to things. And we have specific controls or separations for sky and backgrounds as well. And nearly every component also has a distance fading, because sometimes you only want that in the background or wherever the camera's moving, so we can just fade out all of those settings. So some pretty images. If you ever want to try to cell shade the sky, usually it's a disgusting mess. But if you blend the quantization steps, you can get some interesting looking clouds. Again, some other pictures here, some stylization. We also make use of a custom depth pass, and we use this for doing object highlighting as well. So in this specific scene, we were using ray traced reflections for the water. We couldn't get the shadow to show up. So really quickly, we simply added out some extra passes to highlight the bridge and highlight the water, and then just composite on that shadow. And in the background, we were blurring out the cesium. And we did that in After Effects just simply because we found it a lot more performant or a lot faster just to render out something with a little bit of noise and not have to worry about flickering in the background. For our highlighting, this is also a very common request. We need to highlight specific parts of the project, and we can also occlude specific sections based on that material set. So we've already seen this. I unfortunately do not have time to talk about water, but a really quick rundown. I could do an entire talk on this. We have a custom flow map solution where you can automatically get the contours and generate a flow map with velocity as well. And that looks something like this, where one river is one giant flow all the way through. So if you look all the way in the background, you can see all of that kind of contour around just with one simple map. Maybe next year can do that one. Bunch of other tools I can't explain right now. Special thanks to Parth Patel. He's our lead technical artist.
I would love everyone to give him a clap because Parth, we love you.
Thank you very
down
much.
here.
And if you want to connect, you can quickly grab that QR code, and we'll be here later. All right, thank you guys.